in the time, etc. So modern physics is actually a start. Modern physics is actually a start of a new physics. The first thing these people challenged was the distinction between particle character and a wave character. Einstein was the first person who claimed that mass can be converted into energy and energy can be converted into mass. Previously, the scientists had a belief that energy and mass are two separate entities, and these people claim that no, they are not actually different. They are coming from the same thing. Now, mass to energy example like nuclear weapons, nuclear power plant, formation of a nucleus, formation of a star. So these are example, real life example, or I'm sorry, real examples for where mass really converts into energy. Energy to mass is also now practically proven, but not in our course. So nuclear things are proving that mass can be converted into energy. So these are some of the examples. You have to copy this.
Done, sir.
Right. Now, concept number 2, that was actually a discussion on the nature of light. Light is obviously one of the biggest mysteries for humans, and many big names actually research on this thing. We always believe that light is the fastest entity in this universe, and still now it is the fastest, 3 into 10 to the power 8 meter per second. But the speed of light is actually the source of our vision, our imagination, our understanding. So this is where they research, and the previous scientists used to think that light is a pure wave. These people presented an idea that light is not only a wave, it contains particles also. Now, the particle theory was not acceptable. Why? Because if something contains particles, like dust particles are there in air, but you can feel them, they hit us and we can feel them. The people claim that if light has particles, then they should strike. They should strike because particles have a capacity to strike, like a ball, strike a wall. So that was not visible. This is where this theory was not accepted well. So concept number 2 was the nature of light. You have to copy this. Light consists of particles called quantas.
Done, sir.
So they claim that, and the word quanta, you might have heard about it. Again, that some people have a taste of watching these fiction type movies or fiction. Now it is less fiction, and we are getting closer to reality. Big bangs and black holes, supernova, they are now realities. time travel is still a fiction. Scientifically, it's a fiction also, but many people have a taste of watching such movies, and in that they present it in different ways. Light is actually something which is witness of everything. But when they say the word light, it is not only the visible light. Actually, light indirectly represents all electromagnetic waves. Light indirectly represent all electromagnetic waves. You have to copy this.
Done, sir.
Now, the word quanta was used. Quanta is a common noun. There is a concept of in our English, one is a common noun and one is a proper noun. Quanta is a common noun. Common noun means it's a general word and it represent quantization. That was a concept in our AS also. Quantization. What is quantization? Quantization means something which is countable, like number of students in a class. Like number of students in a class is a quanta. It means that you can count them. But number of light, that doesn't make any sense even. But number of light cannot be found. Number of light sources, they can be found, they can be counted. So the concept is very sharp, very sharp actually, and very difficult to understand in the start, that actually science takes two types of quantities. One quantity which is a count, like I said, number of students in a class. But one quantity is not a count, it is a measure, like the amount of light in a room. You cannot count it, but you cannot measure it. Amount of sound received can be measured using a decibel unit, dB, but you can't count it. So that is why the word quanta is actually a common noun, which is roughly the concept of countable. So you have to write under it. You have to write under it that quanta common noun. That's a very interesting English grammar. That's a class 6, 7, perhaps, I think so, where you study this interesting grammar, common noun and proper noun. It is a countable entity. You have to copy this. Hmm.
Done.
Hmm. Give the heading quanta.
Done.
Energy as a wave is a discrete, or wave nature can be a continuous figure in our conventional physics. But the modern physics consider that wave also consists of particles units, and each packet of energy is called as quanta. So they had a new concept in their time, which initially people got rejected. It got rejected, and they were surprised that how it is possible, because you cannot count, even now you cannot count energy in a room. You can count the number of chairs, you can count the number of lamps, but you cannot count the number of energy units in our room because they are connected. So particle nature of light exists as packets. Wave nature of light, it's a continuation. So we had two physics now face to face. One physics is called conventional physics. This is conventional physics, and this is modern physics. So after giving the heading of quanta, you have to copy this screen.
Done, sir.
Right. Now, quanta is a packet of energy. And as I said, it's a common noun, and it is the concept that energy is quantized. The new physics says that find, it is possible to find countable entities in our energy transmission. So they had a belief that energy travels in very small particles. Energy travels in form of very small particles. Each particle was initially called as a quanta, and it means they had a belief that energy is quantized. You have to copy this now.
Done, sir.
Right. Now, our next concept, energy of a quanta is directly proportional to the frequency of radiation. Energy of a quanta, again, quanta is a common noun, and energy of a quanta is directly proportional to the frequency of the radiation. Radiation can be of any type. It can be of visible light, infrared. So you have to write under it that energy of a quanta is directly proportional to the frequency of the electromagnetic radiation. Energy of a quanta is directly proportional to the frequency of electromagnetic radiation. I hope you got the main concept. What was new actually? These people were talking about countable entities in light, countable entities in electromagnetic radiation. While the previous science, the conventional physics had a view that these entities, in there are no countable entities in light. You have to copy this.
Done, sir.
Good. Now you have to copy this step.
Done, sir.
Now look at the derivation. I have removed the proportionality sign, and then I have put a constant, a very famous constant of this chapter, which is called Planck constant. A2 is obviously a game of derivation. So you have to copy this derivation.
Done, sir.
So this is a derivation, and c is the speed of light, and c is a constant. F is equal to c upon lambda, and Planck constant is the gradient of the graph c. C is the speed of light. Now you can compare now that what is the consequence of this theory. The theory says if you have high frequency, you can transfer more energy. So look at the two waves, one wave with a greater amplitude and one wave with a greater frequency. Now here again a competition started. A competition started the conventional physics between the conventional physics and the modern physics. Now, conventional physics used to say that amplitude is a measure of energy transfer. Modern physics says that energy transfer is a function of frequency. This actually this actually became a challenge for discussion, like you are standing on a seashore and waves are coming. Even though physics do not consider them true waves, they are tides which are coming to seashore. But if the waves are coming, the tides are coming, and a big tide comes, it will transfer more energy. Definitely it will transfer more energy. That is why in tsunami, when you picture them in movies, you show big waves. So it's a very famous, well-established rule that big waves, amplitude waves, transfer more energy. These people put a confusion now. They challenged it and they say no, frequency is actually the source of energy. What it means that, for example, gamma rays have higher frequency than infrared rays. So it means gamma rays will transfer more energy as compared to infrared rays. Now this was a competition. These are the two physics which are now face to face. We had studied in our AS that intensity is a measure of energy transfer. But the new physics says that it is the frequency. So it was a big game, a game of competition, game of dispute. So you have to copy now this screen. Copy it. I'm just coming. Copy it.
Done, sir.
Two signals are face to face. And the first signal means the greater amplitude, and the second signal means greater frequency. So this was the discussion between them, and these people were fighting on these concepts, and just like big polarization was there in science, and Einstein was the starter for that. Many other scientists then supported him. Many other scientists were not supporting him. It is just like the clash between two big physics. The second new physics was very recent in that time, but actually it got fame very quickly. Gamma ray photons have a very high energy, so definitely it was able to give more energy. So if you have a lamp, and you make it brighter, definitely it will give you more energy. You must have seen those projector lamps. They are very intense. And the new science says that this is one thing, but if you change the color of the lamp, you will get more energy also. How you can suppose this is a blue lamp, you change it by suppose ultraviolet lamp, it will give more energy according to new physics. The dispute was later resolved by a new theory that was a turning point in physics, and that actually changed everything. Similarly, just like we are now waiting that somehow in coming years, we are waiting for something huge that will again change the view of physics, view of science. Similarly, it happened there, and they presented a new theory, Einstein, and the theory was called wave particle duality. You have to copy this.
Done, sir.
Now, you have hopefully understood the theory well, understood the dispute well, that wave particle duality came at a point when there was a big conflict between the two physics. There was a particle theory, there was a wave theory. Einstein was the first person who resolved this problem, and he said that actually light has a dual character. What's the meaning of dual character? Dual character means an entity can has two possible characters which are different, but they can be existing together. Just like in every human, there are both characters, good and bad. Some people, the good character is dominant. Some people, the bad character is dominant. Similarly, Einstein suggested that light has both characters. Wave has a wave character and also a particle character. But some cases, one character is more dominant. This is a very interesting and remarkable design of a wave particle duality. You can see a particle here, and you can see a carpet-like diagram which is showing a wave character. So wave particle. So Einstein used a very interesting terminology. He said that every wave has some particle character, and every particle has some wave character. So this was a point where he resolved this discussion. So you have to write it. These two lines are considered to be the changeover in physics, and that actually changed everything. And it was just like when Newton discovered gravity, science took a new turn, And this is a point where scientists believe that science actually took a new birth, because after that it was totally changed, that particles and waves are not two separate entities. They are actually one entity in different disguise, and this is only a type of uh, only a type of appearance which character is dominant. So you have to copy this.
Done, sir.
Now, after that, they translated this theory. This means that every entity both characters. It means that, like, we are particle characters, we have a momentum. When we stand on a weighing machine, we have a weight. But normally, we don't have a wavelength. Normally, we don't have a frequency. Similarly, a wave, light in a room, light in a room, light in a room has some frequency, it has some wavelength, but it doesn't have a momentum apparently. This theory actually challenged this old concept. So this means that every entity contains both characters, wave and particle.
Done, sir.
So they made this theory and they then made it public, and they in the world at that time they had, you have to publish a paper, you have to publish it in public, you have to face the discussion, and that discussion revealed that Einstein and his approach is right theoretically. Obviously, they proved it mathematically also. They Einstein and the people there, they introduced the term photon at that time. Photon is a quantum of electromagnetic radiation. Remember that quanta is a common noun, and photon is the same concept, packet of energy, and it is a proper noun. You have to copy, you have to give this heading.
Done, sir.
Now, copy the definition. Photon is a quantum of electromagnetic radiation. I'm just coming, copy this. Now, the word photon is actually a modified word for quantum, and the actual word was quanta. As I mentioned, quanta is a common noun. They specialize it for energy. Quanta can be used for anything, like we used it for electrons in AS. They use the word photon. You have to copy this. So copy this.
Done, sir.
At this point, uh, at this point, At this point, syllabus want people to remind that microscopic particles, once photon is a particle, once it has been declared that photon is a particle, then obviously we need some parameters to apply to get its energy, mass, etc. So they thought of using electron volt, that is available the smallest unit of energy. You have to copy this.
Done, sir.
Now, give a new heading. Once it is declared that photon is a particle, it is a member of a wave, but it is a particle. So when photon is a particle, like every particle, it will have a momentum. So give a heading, momentum of a photon. This topic was introduced in 2022.
Done, sir.
A photon has momentum, and that the momentum is given by this. You have to copy this.
Done, sir.
Einstein equation. Momentum is mass into velocity. So this is the formula.
Done, sir.
Give the heading photoelectric effect. This is the core topic of this chapter. In every chapter, there is a core topic. So photoelectric effect is the core topic. No need to say that if it is the core topic, this would be the most important topic of this chapter. Photoelectric effect, now getting famous in Pakistan and many other Asian countries also, that now they are also facing the problem of power, electricity. So they are shifting to solar. Solar energy is now getting a very famous thing in many countries in our Asia side, South Asia side, because solar is actually a renewable source of energy. The theory which runs solar system is actually photoelectric effect. Solar energy to electrical energy. So after giving the heading, so better stop here. We can start it in next time. And that would be better for us because it will be a big topic and heavyweight topic. So let's start it in the next class, inshallah. Thank you. Allah Hafiz.
Thank you, sir. Allah Hafiz.